Hey there, this is going to be a nice little video to show you how to complete the lab for this week, the Speed of Sound Lab. So these are the slides that you'll be looking at to help you get through this. Like always, there's going to be some announcements and everything. This week will be a little bit different because you will not be doing activities in your workbook. You're going to be doing a separate lab document. So I'm going to go ahead and move to the beginning of this. So there's only going to be one assignment this week, and you can take your time getting through this, or you could do it all at once. You're going to find a document called the Speed of Sound Lab that has your name on it in Google Classroom. It's your own document, so everything you do on there will just be your own work. On this document, you're going to be doing quite a few different things, so if you need to, take your time to spread out that work over a few days. And then I'm going to have all the instructions on this slide. I'll try to go over the most important things on this video. So I'm going to go ahead and get started with the procedure. So I'm skipping through some of the notes. I would recommend going through that again because this lab is going to be going over some of the concepts from the last 2 weeks, like the speed of sound equation that we've been practicing, the idea of resonance, and also the idea of a fundamental standing wave where you're matching a length to create resonance. So first thing you're going to be doing is some introduction questions. So that'll be the first page. Everything that you're going to do on this document, you will type in green. It's already going to be set as green for you. So if you start typing and it ends up as green text, then you should be doing something right. And so go through those questions. They're pretty simple. If you need to review any notes about what standing waves look like, what a node is, what an antinode, fixed ends, free ends, please take a look at those notes from before. And then you're going to go through that and answer those questions. Here's kind of an example of what you'll be doing. So there's a few arrows that's not going to be on your document. So the first few things you'll be doing is going through and labeling what these different letters are. The first two is either a node or an antinode, so you're just going to type that next to those letters after the colon. C and D is either fixed ends or free ends, and then E and F is practicing the length to wavelength equations for your fundamental waves. Now for the procedure. So for this lab, what you're going to be doing is you're going to be finding the speed of sound. So that's the whole goal of this lab. I'm going to put my video away. So usually we would do this in class with an actual like tube and a tuning fork to try to create resonance in a tube. However, since we can't do that, we don't all have tuning forks, there's a nice little online alternative. So I'll pull that up in a second. This link brings it to you, or there's another link as well. So in order to find the speed of sound, a reminder, you need two values. The first one is the value that represents the tone, which is going to be the frequency. So we're going to be using a few different tuning forks that create set frequencies, meaning that no matter what, when you hit the tuning fork, it makes one pitch the entire time. To find the wavelength, we're going to be trying to match the length of the tube with the fundamental frequency of our tuning fork to create resonance. So the same thing of trying to match the frequency of a wine glass to make it shatter like you looked at last week. So we're going to have to figure out what length of a wave would fit into this tube at its fundamental frequency that would match that and create resonance. So when you do that, you're going to be measuring on here the length of the tube when you actually match it, and you're going to use your length to wavelength equations for an open tube to find the wavelength. So let me show you what I mean by that. So that's what a tuning fork looks like. It's an animation, of course, and then here's your wave that you're going to be looking at for your wavelength. So quick demonstration of what this would actually look like in real life. I'm going to show you a portion of this video. There's a second video on here too that kind of demonstrates it. So let me really quick cue this up.
Here's another trick you can try to instead measure the speed of sound. Take a tube that's open at both ends and dip it in water. Then with another tuning fork of known frequency, try to find the resonance. 1/4 the wavelength seems to be about 29 centimeters.
So what he did there is what we would have done and are kind of doing in this lab is we are changing the length of the tube until we can match that natural frequency, and then we're measuring how much with a ruler, how many centimeters is that length that fits that wave inside of it. So if that's the length, we can use our equation for the wavelength of an open tube. 1/4 a wavelength equals L to calculate then the wavelength. So I'll show you kind of what that looks like as we move forward. So next thing we'll look at, move on with our slides. There's another video kind of showing that, is matching the natural frequency. If you remember from what we've been doing the last week, we want for an open tube, we would have one open end, an antinode at the top, and one closed end, a node where it hits the end or the water in this example. So to look at that, if we think about what our fundamental standing wave would look like, this is what it would look like when we would match that resonance or when we match that frequency. So thinking about what this picture here shows you, what is the wavelength portion or proportion to the length for this. So if you look at this, this is 1/4 of a wavelength. So that means we would use that equation for that. On the website, you're going to see that you can actually find, it'll tell you right here what the length is of the tube. So that's basically the procedure. So a few things that you're going to be doing, you're going to go to this website, and I'll actually click on it and go to it with you. You're going to have your document open. Okay, after you read through the procedure, watch this video, I would answer these questions to make sure that you have a great idea about what you're supposed to be doing and what everything represents. But then one of the most important things is this right here, your data table. So first thing you're going to do is you're going to click the first tuning fork. Okay, so it's 440 hertz, and you're going to record that into your data table. So I'm going to write 440 Hz. Next thing I'm going to do is I'm going to try to figure out what the length of the tube would be that would fit a fundamental standing wave. So I'm going to be changing this until I get it about like that. So that looks like it's quite about at an open antinode right here. And that would be what the fundamental standing wave would be for my sound wave. So I'm going to look at the length there. It tells you right here, it's 19 centimeters. However, if you look at your data table, we're always going to be measuring it in meters. So 19 centimeters, if we move the decimal over twice to the left, it's going to be 0.19 meters. Okay. So then if we look at that, that's only 1/4 of a wavelength. So we need to use our equations from what we've been learning about to find that. So it's going to be kind of down here hidden. My little black bar goes away. The length of a tube is 1/4 of a wavelength. So if we rearrange that, if we have the length as 0.19 meters, if we multiply that by 4, we get the wavelength. So if we do 0.19 times 4, we're going to get trying to do the math in my head, 0.76. Hopefully that's right. I just did the math in my head, and that's meters. So now we have frequency and we have the wavelength. Last thing you're going to do is you're going to be calculating the velocity of your wave by doing the wavelength times the frequency. Okay, and all the times when you're doing this, when you're finding the wavelength and when you're finding the velocity, you want to put those calculations right here. So I made spots for each of those 3 frequencies for you to put those 2 calculations. So each of these should have calculation for wavelength, calculation for velocity. So when I do that, I think that'll end up being about 334 meters per second as my speed. So I'm just guessing that right now. Don't have a calculator. So that's how you go through and do that. You're going to then change it for each of your different frequencies. So I'm going to change the tuning fork, and you barely tell it changed to kind of a pinkish magenta color. And if you go to 660, it kind of turns green. So each of these is going to be creating a different wavelength, and you have to adjust it to make it so that you have different water levels. If you want to make really small adjustments, you just click this 1 centimeter up, 1 centimeter down. Most important thing with that is that you are recording this in meters, even though it tells you the centimeters here. So just move the decimal to the front of that number. The last few things you're going to do, so you're going to go through, calculate that, you're going to find the other two frequencies, record all of that data, and then after you've found your 3 speeds of sound, you're going to find the average speed of sound. Now, most likely what's going to happen is because we're doing this on a computer simulation, you're actually going to get really close values. So your average should probably be really a pretty good average, and it's going to be pretty close to the known speed of sound. So that's the basic procedure. I'm going to put this video right here. And then I'll put another video a little bit later on with some demonstrations on how to calculate this if you need some more help. And then you also have a slide that tells you what you need to have in your conclusion. So that's the last piece. So if you can, try to get through all of that this week, and then you'll be done with that lab report, and you can turn it in. So if you have any questions about what you're doing, please let me know. But that's my video, and I hope you guys have an easy time doing that this week. If you have any trouble with the website, please let me know. I can see if I can figure it out.